Hello everyone. In this class, we are going to study about the turning moment diagrams. Okay, and also we are going to study about the uses of the turning moment diagrams. Okay, so first of all, let us know what do you mean by the turning moment diagram. So, turning moment diagram is defined as a graphical representation of torque versus crank angle. It is a graphical representation of torque versus crank angle. Okay, where T is the torque here, which is represented on the which is taken on the y-axis, and theta is the crank angle, which is taken on the x-axis. Okay, so the graphical representation between this torque and the crank angle is known as turning moment diagram, and this graph is drawn for various positions of the cranks. Okay, it is drawn for the various positions of the cranks starting from 0 to 360 degrees or 720 degrees. Okay, so what is a turning moment diagram? It is a graphical representation of torque versus crank angle for the various positions of the cranks. Okay, so now let us understand what are the uses of this turning moment diagrams. Okay, so for explaining this uses of the turning moment diagrams, let us consider the turning moment diagrams for the different engines here. Okay, that is for a single cylinder double acting steam engine, and for a four stroke cycle IC engine, and for a multi-cylinder engine. So I would like to explain you the uses of the turning moment diagram by considering a four stroke cycle IC engine. Okay, so now you can see here this torque is taken on the y-axis and theta is taken on the x-axis. So that is when the cranks is at various positions, when the crank is at various positions here, so the torque value is shown on this vertical axis. Okay, so then what is the use of this turning moment diagram is, now the area under this turning moment diagram, the area under this turning moment diagram, so this area will give you the work done per cycle. Okay, this area will give you the work done per cycle, how much work is done per cycle. Okay, so if I divide this work done per cycle, if I divide this work done per cycle by crank angle, that will give you the T mean. Okay, if I divide this work done per cycle by the crank angle, that will give you the T mean, that is mean torque. Okay, that is mean torque. Then again, if I multiply this mean torque, if I multiply this mean torque with angular velocity of the crank, with angular velocity of the crank, that is omega, so this will give you the power developed by the engine. This will give you the power developed by the engine. Okay, so these are the three things we can determine by using this turning moment diagram. That is, first we can represent, you can find out the work done, that is the area under this turning moment diagram will give you the work done. And if I divide this work done by the crank angle, and that will give you the T mean, that is mean torque. And if I multiply this mean torque by the omega, that is angular velocity of the crank, that will give you the power developed by the engine. Okay, or the power consumed by the engine. Okay, so then what is this area above this mean torque line? This area, what this area represents here? So this area represents the excess energy stored by the flywheel. Okay, this area represents the excess energy stored by the flywheel. Okay, excess energy stored by the flywheel. So whenever the energy is required, whenever there is energy, supply of energy is required, this flywheel releases that energy. Okay, this flywheel releases that energy. Okay, so these are the main uses of the turning moment diagram. Okay, so I hope you have understood the definition and the uses of the turning moment diagram. So if you have understood this, in the next class we will be studying about the energy stored in the flywheel, and as well as we will be solving some numerical problems on this turning moment diagram. Okay, so thank you everyone.